Okay guys, this is lesson 7.1. We're going to be finding square roots. So in the first slide, it defines a square root. The square root of a number is a number that when multiplied by itself equals the given number. Every positive number has a positive and a negative square root. These are from our integer rules. A perfect square is a number with integers as its square roots. So you would get an integer, meaning you would not get a decimal, okay, for the perfect square. So when you look at the symbols that we'll use, you can see the radical sign. It's used to represent a square root. The number under the radical sign is called a radicand. And this is what we're talking about when we say positive square root. We sometimes refer to it as a principal square root. Okay, so in the first one, you can see is the positive square root. 16 is the radicand, it's under the symbol, so we're wanting to know the square root of 16. What number times itself is equal to 16? And because we want this positive value, right, the answer would be 4, because 4 times 4 equals 16. Now, if we want there to be, sometimes it's specified that we actually need -4 as the answer, because for 16 itself, the square root of 16 has 2 roots. We know mathematically that, I'll do it in the middle here, 4 times 4 equals 16, and because of our integer rules, -4 times -4 also equals a positive 16, okay? So the 2 roots of 16, if I'm not talking specifically about give me the positive root or give me the negative root, if you're asked for the 2 roots of a number, you would literally say 4 and -4. Or you could use this kind of symbols, plus or minus on top of each other, 4. So we just talked about the positive one. You will see literally you don't have to put a plus sign in front of it to mean positive. However, if we want the negative root, so this negative sign in front of the square root of 16 is kind of read as the opposite of the square root, right? So the opposite of 4 is -4. That tells us we want that negative. Here's where they talk about both roots. You want the positive root and the negative root. So plus or minus 16 just means the value +4 and -4, and it's just written like this, just to be a notation. Now, you will never see this, because there is not a mathematical rule. It's kind of like undefined, right? It's an error. It doesn't exist in our real number system. This doesn't exist in our real number system with our rationals, our irrationals, and everything. Because there is no number times itself that would give a value of -16. Because +4 and -4 are on opposite sides of 0. They are not the same number, right? So that's the only way to get -16. If you tried to do a negative number and then take the square root of it on your calculator, it'll tell you error. And the reason for that is in math we have a whole set of numbers, or actually one number in particular, that's called imaginary, which would take into account the possibility of taking the square root of a -1, and that number is the lowercase I. It's called an imaginary number, which you will not see until maybe your junior or senior year in high school. So just be aware. So let's do some examples. We want to find the 2 roots of the number. So we're taking the square root of 36, and because it said find the 2 square roots, we want the positive value and the negative value. So for 36, ask yourself, what number times itself equals 36? You should remember this from your multiplication tables. You could use the back of your agenda to look up your multiplication tables, and you can also use the square root button on your calculator. Depending on the type of calculator, you have to hit the square root button either before or after entering the number. So for the square root of 36, the answer is 6. So the roots are 6 and -6, and I would allow you to write them as plus or minus 6. Either one is acceptable. For 100, you have 10 times 10, right? So you have 10 and -10, because -10 times -10 is also a positive 100, so plus or minus 10. And for 121, it would be 11. So 11 and negative 11 are the two roots, plus or minus 11. I think in 7th grade we talked about, or we should have, the perfect squares, and I wanted you to memorize them up to 15, but if you list them out and kind of make a chart for yourself, the first 15 perfect squares would be the product of the first 15 integers. So 1 times 1, then 2 times 2, and 3 times 3. So you can always go through them in your head. So we could list them as 1, 4, 16, oh, whoop, I almost forgot 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. These are the ones that are most commonly used, and then of course you can use your calculator to evaluate anything beyond that. So basically, if you took the square root of these numbers, 1 would be the perfect, 1 is a perfect square root because the square root of 1 is 1. 1 times 1 is 1. 4 is a perfect square because the roots of 4 are 2 and negative 2. 9 is 3 times 3, 16, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on to get all the way up to 225. So you might want to make yourself a table of those to help you so you don't have to use your calculator every time. Okay, next thing we're going to do is find the square root or roots. So this time now we're going to let the symbol tell us, the radical sign, and whether or not it has a negative in front of us, tell us whether we want the positive root or the negative root. So since we have the negative sign out front, we want the opposite of the square root of 1, or the negative value, which is negative 1. Looking at 5, in this case we want the positive or negative. We want both roots of the square root of 4 over 25. When you have the square root of 4 over 25, it's the same thing as the square root of 4 over the square root of 25. So when you evaluate it, you get 2 over 5. Since we want both the positive and the negative value, you could write it as plus or minus 2 over 5. Okay? And then when you start to get into the decimals, now this isn't a perfect square. We would have to evaluate it using a calculator. So, depending on the type of calculator you have, just the regular old TI-30 would be entering the number 12.25, and then you'll see the square root button right next to the division sign, and when you hit that, you'll get 3.5. We wanted the positive value of that. If you have one of the other fancier calculators, it might be the second feature, and if you have to enter it first, you would hit second, and then your squared button to activate the radical symbol, then put in the 12.25 and hit enter. So hopefully you can figure that out or ask for assistance. Alright, squaring a positive number and finding a square root are inverse operations of each other, and we will start to use these then to evaluate expressions and solve equations. So we want to use our order of operations. In order of operations, so to evaluate the expression, you would have to use order of operations, and you would treat the square roots as the inverse of the squares, so you would do them after the parentheses. So for the first one, we would do 12 minus 3, and then evaluate the square root of 25 to be 5. We would multiply before subtracting, so we get 12 minus 15, therefore the answer is negative 3. In the next one, when you evaluate, look at what's underneath the radical symbol, and if it can be simplified, which it can, we will be evaluating the square root of 4, because 28 divided by 7 is 4, and then adding 2.4. So the square root of 4 is 2, plus 2.4 is equal to 4.4. In the last one, do the parentheses first, which would be simplifying the square root of 4. 15 minus the square root of 4, which is 2, and that is what's being squared. So 15 minus 4 is equal to 11. The last example is very similar to activity 2. So if we're told that the area of a circle is 2,826 square feet, we want to write and solve an equation to find the radius of the circle using 3.14. So let's just jot down some of the things we know. Okay, we know the area formula for a circle to be pi r squared. So if we substitute in the value, we get 2,826 is equal to pi r squared. To solve for r, the first thing we'd have to do is get rid of pi, so we'll use the inverse of multiplication and divide both sides by 3.14. When we take 2,826 divided by 3.14, we get 900 is equal to r squared. And again, how we undo squaring a number is to take the square root. So we want the square root of both sides. So we basically want to find out what number times itself equals 900, and that is 30. So r would be equal to 30 feet. Anytime you're doing a dimension, make sure you have a label.